Hello, everyone. Give us a second to load on through. I still see some people in that waiting room. There we go. I think we have just about everyone loaded in. Give you all a second to connect the audio so you could hear. Oops. A couple extra people. Okay, perfect. Well, welcome, welcome. For those of you who have been here before, welcome back. I recognize some of the names. For those of you who have not, we are the Marine Environmental Education Center located out on Hollywood Beach, Florida. Unfortunately, we are still closed. We don't know exactly when we're opening yet. So we still want to continue on this really cool webinar series. We want to provide some awesome resources for people who would usually be coming to visit. Some of you people might be stuck inside as well and want to learn some cool stuff. So we reached out to all of our marine science friends, and we're lucky enough today that we are speaking to the awesome Rachel Silver, one of my closest and dearest friends. We will be talking today about shellfish biology, the filters of the sea, why things like that are so important. I know we talk a lot about turtles here because they're so charismatic. We're like, oh, the turtles are so cute. But there are so many components to the marine environment that are vital for it to function correctly. And today we're going to be talking about one of the major components of that marine environment. So right now we do have everyone muted. So please keep yourself muted. Even if you have a question, it'll make it so much easier for you to hear Rachel. If you do have any questions or if you're having issues even with technology, feel free to put it in that chat. Christina, Carly, and I are all here to sort of facilitate and help from afar if we can. Otherwise, if you have any questions, you can direct message us, but Rachel will answer all of the questions that are in that group chat at the end. So whenever you're ready, Rachel, feel free to take it on away.
Okay. Well, hello, everybody. My name is Rachel Silver, and I am here to talk to you guys today about some shellfish. A little bit of background for me. I got my master's at University of Stony Brook, where I did a lot of communication and community outreach with the Shinnecock Bay Restoration Program, working on oyster reefs, habitat restoration, eelgrass, all that kind of fun stuff. So shellfish and oysters to me have always kind of been a pet project and a fancy of mine. One, because they're delicious, and who doesn't like a really nice, white wine clam linguine when you can, as long as they're fresh. And I was like, oh, I want to learn more. And the ocean is one of those wonderful things where sometimes knowing more doesn't make you feel better on the inside. And the more I learned about clams, the more I was fascinated by them, and the more I was like, oh, they're very interesting. They're very much a filter. And now when I eat my clam linguine, I turn off the science part of my brain and just focus on the fact that they're delicious and not what they actually do for the environment. So today we're going to talk about a little bit of what they do to the environment. My goal is to not dissuade you from never eating shellfish again, just so that way you understand why they're so important and why we should really be doing our part to help them. So let me go ahead and share my screen and we will get going. Okay. If I could just get, if this is gonna load, there we go. Can everyone see? We're good? Okay, awesome. So we're gonna be talking about the ocean's filter. So just first and foremost, how does the ocean stay clean? It covers the majority of the ocean and it circles all day and it circulates, but like anything, it gets dirty. You have to go in and take your car for an oil change and you get your air filters changed, but what filters the water? First and foremost, it happens with producers, so your bottom line producers. So think plankton, microalgae, all of those kinds of stuff. The plant stuff that's going to convert CO2 rather into oxygen and create those baseline basic nutrients. Everything else needs to grow. And then if you get too much algae, what are you going to do with it then? That's where your second level consumers come into play. Oh, here's some photos of algae that I forgot I had. So algae, some people think of it as like very small things. but it can be everything ranging from a microorganism that you can't tell to like that green slimy stuff you might see at the beach sometimes if it gets kind of gross, especially in Florida. You guys might have some red tides. On Long Island we had red tides. They're becoming more and more apparent. But however, algae also takes the form of larger organisms like kelp forest, so it's still a form of algae, just a lot bigger. So from there, we go to consumers, and those consumers are anything from microbes to shellfish to even as big as, you know, blue whales eating all of the krill and plankton and that kind of stuff. And these guys are going to be doing something called filter feeding, which we'll talk a little bit more about in a little bit. And that filter feeding, what they're doing is they're literally sucking in all of these gallons and liters of water, passing it through a filtration system internally, filtering out the water and keeping those particulate matter. Like with any other filter though, sometimes they're going to absorb things that aren't necessarily basic nutrients. They're going to absorb things that might be pollutants or toxins or anything along those lines. And that's what's going to keep the ocean clean, because they're going to filter all of that kind of stuff out and then pass clean water through. And shellfish consume or encompass everything from lobster, shrimp, scallops, oysters, clams, what have you. They're all considered shellfish. And we'll get into kind of the nitty-gritty, I think, on the next slide of just what the difference between clams and oysters and then the rest of shellfish. So then from there, how this nutrient cycle continues, once it's gone through all of these higher level organisms, once they all pass away, we get to the decomposers, which are then going to break down all of these kinds of complex materials and put them back into a basic function that will circle back into producers and start this cycle all over again. It's also important to note that because shellfish like clams and oysters are on the base layer of the ocean floor, they're more in contact with those decomposers. So they're going to have a more direct connection and will sometimes circumnavigate that extra step and work right with those decomposers. So that's a fun fact too. So they're not only are they sucking in all of the water grossness, sometimes they're going to suck in some of the dirt grossness too. So, but we're going to talk specifically about shellfish. And when I say shellfish, I'm talking, for the rest of today, I'm going to be talking about clams, oysters, scallops, all of those things. I do want to highlight just really quick on the slide because I think it's a really fun fact. If you see all of those little blue dots on the scallop right here, they're actually eyes. And there are 108 of them-ish per scallop, which I think is really funny because they never see the net coming. That's my joke for the day. You are welcome. So the difference between shellfish and bivalves. Shellfish is a fisheries term that refers to an exoskeleton-bearing aquatic invertebrate. So I believe there was a talk a few weeks ago about invertebrates, and that is just another fisheries term referring to anything that doesn't have a skeletal system or specifically a backbone inside of their person. All of their bones are on the outside. And that refers to shrimp, lobsters, oysters, mussels, scallops. Shellfish, however, are not technically fish. While they are called shellfish, it's kind of like how starfish used to be considered starfish and now they're sea stars because they're technically not fish and it's confusing for everyone involved. So bivalves specifically are shellfish that identify as soft body invertebrates. So they're, again, no backbone, with two shells that connect at a hinge point and close up. And that includes over 15,000 species from mussels, clams, scallops, oysters, all of those delicious things that we love for dinner. Bivalves, however, do not have an exoskeleton and will actually grow their shell through their life cycle. So they will continue to, as they grow and mature, that shell gets bigger. So if you find a really big clam shell at the beach, it's probably a pretty old clam. Same with oysters and things like that. So a little bit more about their basic biology. We're also going to be talking today specifically more about saltwater bivalves. There are freshwater bivalves that are found in like lake systems. I think there's like the zebra mussel and a few others that have become more invasive species. But I'm going to be talking more about saltwater bivalves and clams, and those live in brackish waters. Now, brackish water is that intertidal zone right between where freshwater comes in and where the ocean meets. So think like any sort of sound system, like the Chesapeake Bay, we're going to focus on a little bit later. Florida has a lot of these brackish waters. Long Island has a lot of brackish waters. Those in-between zones are really where shellfish love to thrive because they're getting all those nutrients coming in from everywhere all at once. This includes many different species, and on average, they will suck up and filter over 50 gallons of water a day per unit. So that's per one oyster or clam. If you think about like the Chesapeake Bay, for example, who's had a large history of shellfishing over the decades, the Chesapeake Bay water system used to be filtered. Its entire water body would filter and turn over once every 3 days. Currently, with the current populations that are found there, it would take nearly a year for that same body of water to filter over because of the decline in shellfish that are present in that area. And as we've already mentioned, these organisms are vital to that nutrient cycling because they're going to transform those basic nutrients into nutrients that are more complex for larger ecosystems, while also converting some of those back into basic functions and keeping everything clean. So how do they do this? You know, all you see is this little shell, and you might see that little thing that your mom chops up and puts in for scallops, and they're delicious, absolutely delicious. But like, what is going on? So here we have the anatomy of a clam. This is going to change ever so slightly when it comes to oysters or scallops. So this isn't universal, but we're just going to talk about clams mostly because it's the best diagram I have found. So what's happening here, you have these two anterior abductor muscles, and those are the muscles that are going to open and close the clamshell. So that's also what's going to fight against you when you're shucking an oyster, when you're shucking a clam, all that kind of stuff. You have the mouth siphon here. So if you see on some clams, sometimes they have that really long spout that pokes up. That's that siphon. And that's what's going to suck in all of the water. From there, it's going to pass into the stomach through its filters, which are over here, and their gills. And then it's going to pass all the way through the stomach and go right out the other end, just like most food for everybody. They do actually have blood in their body. You wouldn't notice, though, because it's invisible and it's see-through. So when you cut them open, you're like, oh, they don't bleed. They do. You just don't see it. And there again, so they have all of these different stages of filtering the water, and what these gills and siphons are going to be doing is they're going to be catching that particulate matter that we can't see in the ocean and collecting them, transferring it into the stomach, and gobbling it all up. This foot here, that's what it uses to move and to dig. So some of these clams and oysters, for oysters specifically, they will attach to a hard surface. So whether it's the bottom of a boat, whether it's a dock, whether it's another oyster, they prefer other oysters, but whatever they can adhere to, they'll stick to. For clams, they will actually use that foot and bury into the sand to protect themselves, pop up to eat, or just like send its little siphon up and then stay in the sand. There are some clams that like to come out when it's warmer and stay when it's colder. Much like me, I would also much rather just stick a straw out to get snacks when it's cold and then hide in my little cocoon of blankets. But, you know, sometimes you gotta go to work. So how does all of this play in to their life cycle? How is this all gonna work? So for oysters and clams, they're all what's called broadcast spawners. So they're going to release into these large plumes eggs and sperm into these giant clouds, and those are going to meet, create the fertilized egg, and then approximately 2 weeks later of this little itty-bitty thing floating around, getting sucked up and chomped on by other things, whoever remains becomes a little bit of a larger clam, and then they become this little itty-bitty baby oyster that looks like a clam with this little foot. And what this foot is going to do, it's going to start to try to find something to adhere to. they're going to, while they're free floating, they're at high risk of being eaten, and that's not the ideal point for them. So what they're going to use these tiny little feet here, these grabbers, to adhere to something so that way it can remain for the rest of its life. For complex oyster reefs, they're going to adhere best to other oysters, and that's why you kind of see oysters forming clumps. If not, they'll adhere to whatever it is that they can find. Sometimes it's a piece of grass, sometimes it's a piece of plastic, sometimes it's a rock, genuinely whatever it can find. And from there, it takes them about 2 to 3 years from that spat on shell, is what it's called when they first stick, to reach maturity and then begin that cycle. So when you see, you might have seen on some shells, you see like little dots all over it. That is potentially spat on shell, which those are little baby clams, little baby oysters, adhering to form the next part of their life cycle. Spat on shell is specific just to oysters. Sorry for that confusion there, just to make sure. And then little clams will just be like little itty bitty grains of sand almost. There again, they'll just kind of bury into the sand until they've reached maturity. But there again, it's still about that 2 to 3 years. And this is also, this cycle of broadcast spawning is also why you might have heard from like the old wives' tale of don't eat shellfish unless it's months that end in R. It's because if it's not a month that ends in R, they're getting busy and they taste a little funny. So if you eat shellfish in months that do not end in R, so like July, June, August, the nice warm summer months, they'll be a little bit saltier and a little bit tangier because they're doing other things. So from there, what are they eating? We know they're eating these basic things, but this all goes back to that filter feeding process I was talking about earlier, where they cycle the water, they feed on those microscopic plants and nutrients. I don't know why that skipped. I am so sorry. Going back. So they're gonna eat those microscopic nutrients, and they can filter up to 1.3 gallons of water a day. And that's why I keep referring to them as a Brita filter, because they're gonna filter that water the same way your Brita filter is gonna do it. They're gonna remove all the stuff you don't necessarily want, keep it, eat it, recycle it, poop it out, have at it with it. So you might say like, okay, but can you actually see a difference? So here you can see an inlet. This is in Long Island that is not connected to an area that has shellfish. This area used to have shellfish once upon a time, no longer does. And here's a nice, healthy, fresh body of water, not fresh body of water, it's an ocean, that has more area to cycle and filter and all that kind of stuff. And then here is, I was on a field day, we were out sampling, and we decided to collect buckets of water from different areas along the bay to highlight just what the water looks like. So this was an area where there was a lot of shellfish, medium shellfish, not a lot of shellfish. And this is all of 5 miles apart, just as an idea of just how much of an impact these critters can make. So what does a healthy oyster reef look like? It's gonna have a bunch of different layers, and they just basically grow on top of each other. So you're gonna have that hard substrate bottom, that intertidal zone that tends to be a little bit rockier, harder to walk on, not great for beach days. You're definitely gonna want water socks. And from there, they're gonna start building up. And it's gonna form this really hard structure on the inside. And then they're going to continue to build out. So this reef veneer is basically those active adult oysters who are actively filtering, feeding, and growing day to day. And this is the framework. The taller the system gets, you're gonna have some oysters that spend some of their days outside of the water, some of the time in the water, depending on tides. These are gonna be a very hardy brand of oyster because they can do that transition. Shellfish can do this depending on the species and where they prefer to live. but it's very common to have them be half out, half in, and that's just part of their natural cycle. They do cement to each other. It is very difficult to get them apart, and that's one of the reasons why we love them, because you can grind them up and turn them into other things, or you can eat them. They were very influential in the beginnings of a lot of seaward societies around the Americas. So what's all happening where there's more and there's less? These shellfish are going to improve water quality by keeping all this harmful algae in check. They're going to keep this out of the water. Stream cycling is happening. They're also, by cleaning the water, are providing a healthier ecosystem for everyone else. So when you think of baby flounder, baby shrimp, all of it, more oysters mean that the water is going to be cleaner and other people are going to want to live there. Because if you have dirty water and your backyard is a mess, you might not be able to live. You're not going to be able to see. Predators are going to find you because you're just bumbling around, and it gets a lot trickier. So that is one of the key reasons as to why shellfish are so vital. But I want to switch gears and give you guys a little bit more of a background of the history of the oyster industry and just how we got to these kinds of degraded water bodies that we're seeing today. So we're going to focus for the next little bit specifically on the Chesapeake Bay, which incorporates Maryland, some parts of Delaware, some parts of Virginia, this whole area in here. The Chesapeake Bay and areas of Long Island too, especially toward the harbor up near the Hudson, there are historical records that have shown that these bodies of water used to be as clear as the Caribbean. Like that clear Florida water that you're used to, that used to be in New York. And it also used to be in the Chesapeake, because these oysters would turn over those bodies of water in days as opposed to what we're seeing now. The Chesapeake Bay specifically was an extremely productive, complex ecosystems. And in a lot of these cases, in a lot of these scientific papers, oysters are considered ecosystem engineers, because they're going to be the ones who build an ecosystem to make it functional for everything else. They're going to provide little hidey holes for baby fish. They're going to provide areas for seagrass to grow. They're going to act as a nursery for a lot of other very important fisheries. So for this one here, we were looking at historical studies that have documented the dramatic decline in oysters in the Chesapeake Bay, specifically in the 1800s. So when explorers first started settling in these areas, oysters were so dense and so thick that you could probably walk across the Chesapeake Bay and a man who's 6 feet tall would never get his hat wet, because it was that shallow and that dense with oysters. And even today, it's still extremely shallow. So when it came to large fishing vessels, they had to dredge and dig out a lot of these oysters so that way the ships could get in and not be damaged and just have enough clearance to dock, period. So they had to dig out a lot of these oysters to make that happen. Then they realized that they were also really tasty, and they're like, oh, it's cheap food. We can grind them up into pavement, but also the Queen of England loves them and used to actually have American oysters shipped to her so she could eat them for dinner every single Sunday. So I'm not sure how many died on the way to England, but I know she used to eat them every single week because she loved them so much. So they started just digging them up, and they thought, well, they keep reproducing. There's so many of them, we can't possibly ever harm them, right? Well, they hit a population peak of peak harvest in the late 1880s, and they hit a critical point of population removed that the population just collapsed. And this is due to the fact that they are broadcast spawners. So if they're releasing everything into the ocean and it all mixes up and connects and then settles, if they aren't in close enough proximity to one another, that broadcast isn't going to happen, and you're just spewing, and that's it. It just goes away. It just floats away. So the density of shellfish is also incredibly important, because you want to be able to make sure that that broadcast spawning is going to be effective. And as these populations were declining, they were seeing more and more reports of anoxic water conditions, and that means it smells a lot worse. Things don't want to live there. You're going to see declines in population. You're going to see more algae blooms. You're going to see just more declining water quality, because the filters aren't there. The Brita filter's been removed. It's been chucked. It's now your pavement. It's not filtering anything anymore. So with those anoxic conditions, they saw an increase in plankton blooms. They saw a decline in low spat survival. So that's that tiny larval stage. They weren't being able to cement to anything. And according to a study done by Beck et al. In 2011, global estimates are about 85 to 98% of oyster populations have declined, have gone away, about 85 to 98% of them. At the peak of this decline between 1880 and 1910, that fishery landed 160 million pounds of meat. That's just the inside of the oyster. That doesn't include any sort of shell mass. The Maryland portion of that population declined 50% in about 80 years. And that's what we're seeing here, is this very sharp decline. You can see a peak harvest and then it just drops off, because you have all of these factors working against them. Because once the population isn't big enough so that way broadcast spawning can work, you're not going to have enough to filter the water. And then once the water isn't filtered, the water gets dirtier, and it just keeps this really nasty feedback loop. So again, these are some of the historic harvest photos from the Chesapeake Bay area. And like, this is a whole human being, that's a whole man on a pile of oysters roughly 4 stories tall. And not only did they use these for food for low-income communities, they also turned a lot of the shells into pavement, which is why in a lot of areas like on Long Island, New York, and special coastal communities, if you're digging up your garden and you're finding shells, you're like, how in the world did these shells get here? It's because of these harvests. They used to use it as a pavement, so that way all of the buggies and carriages and cars could travel a lot easier, and they weren't on just dirt roads. So there again, the keys to these population declines are over-harvesting due to fishing gear like trawls or bottom dredging, where they'll actually think of a giant rake. They will rake the bottom of the ocean to get those shellfish, because they're so hard to take apart. So you have those really unhelpful fishing tactics. And then you have habitat destruction, because not only are you removing the oysters, you're removing the habitat they've built for themselves. So now, even if there are some remaining, they're not going to be able to stick to anything. Then you're going to have poor water quality, because if we've removed the oysters, this is what the water is going to look like. It's going to be green, it's going to be cloudy, it's going to be gross. And then from there, we have things called shellfish poisoning, which is now becoming a larger problem for sea turtles, for whales, for a lot of large mammals that eat shellfish. These shellfish are now absorbing higher percentages per unit of toxins that will cause things like paralytic shellfish poisoning, where they're completely paralyzed, amnesic shellfish poisoning, where you just completely lose your memory, along with many others. And these have also been seen in humans who eat shellfish from contaminated waters. So that positive feedback I was talking about. So we have destructive overfishing, which then leads to a decline in the population, which then creates this giant feedback loop of a decline in water quality, which leads to increase of harmful algal blooms, which then creates a reduction in recruitment or that successful broadcast spawning. And all of these affect each other. All of these make each other worse. And all of these cause an even more significant decline in oyster populations. So in case we haven't covered it enough today and you guys aren't sick of me yet, why should we care about the ocean's Brita filters? We should care about the ocean's Brita filters because they are historically vital to the growth of many cities. Cities like New York, cities along the Chesapeake Bay would not be what they are today if it wasn't for the economic impacts of the oyster industry. They would not have the foundations to where they've built their buildings if it wasn't for crushed oysters, and they wouldn't have had the clean water they needed to create the societies and the cities that they did. They are ecosystem engineers, so not only are they important to water quality, but they are important to the recruitment of juvenile fish of many different species that are good for recreational fishermen, commercial fishermen, and everything in between. Again, natural water filtration, they will halt that positive feedback loop if we can help recruit more oysters, and there are a lot of economic benefits that come with more oysters and more shellfish cleaning the water. Some of these economic benefits include it costs less to restore an oyster reef than it does to restore eelgrass. And for that, eelgrass is those really nice, pretty grasses. They're very common in Florida as an intertidal zone. Lots of small juvenile fish like them, but it is very time intensive to restore an eelgrass. It involves collecting all of the grass, sorting all of the seeds. Taylor can talk to you at length of eelgrass restoration because she has been one of those people who have gone down in her scuba suits and individually picked blades of grass. Whereas with oyster reefs, all you have to do is, if you have healthy oysters from that area, just dump them in, and as long as you've got a pile that's big enough, they'll take care of the rest. You don't got to check on them. They'll be fine. It'll be great. Oyster reefs will continue to support local fisheries and commercial fisheries. So if you have a healthy oyster reef system, you're probably going to have more black sea bass, more flounder, more everything you want to catch, everything you want to eat, because the water's going to be healthy and they can show up there for their own reproductive needs. It also will increase recreational beach activities. There have been some estimates. I cannot see the rest of my point, and I'm so sorry. There have been some estimates that have shown that these improvements will go up about $73 million today in today's money because of the improved water quality. So for areas who rely very heavily on tourism and beach tourism, you want clean water. And if you don't have clean water, people aren't going to want to visit you to go hang out in the water because your water's gross. So if you have a healthy oyster population and healthy clams, you're going to have clean water. People are going to want to visit, and they're going to want to hang out because it doesn't smell weird and they don't have to worry about green things in the water. There again, that increase in recreational fishing is substantial. You're looking at about 100-fold increase in the cost of improvement. There's a potential increase for over $3 million in just recreational fishing. And that comes from, those numbers are coming from like permits, reselling the fish, the shellfish, and the fish that you're caught because there's now a habitat for them. The issue that holds back a lot of people and a lot of environmental groups from doing more shellfish restoration is because it is a very slow return on investment. So if, let's say, all of us here were to go out and convince every shellfish group, I want you to dump 1 million oysters into the bay and we're going to clean it up, not a problem, by next week it's all going to be filtered. The problem is it takes them a while to set up that very complex, healthy oyster reef. If they broadcast spawn, those new oysters, like we talked about earlier, will take 2 to 3 years to reach maturity to create those same filter loops that we would like to see of them processing 50 gallons of water a day, and helping those kinds of things. So it does take arguably about 5 to 10 years to see any sort of return on investment for those kinds of big scale conservation efforts, which is why for a lot of groups it's hard to to maintain funding sources, because a lot of people want to see an improvement tomorrow, not necessarily 10 years from now. But when it comes to ocean health, we have to start thinking in terms of decades and not in terms of hours and minutes. So how do we get there? How do we even get to the point where we can all have Caribbean blue waters in New York and Maryland again? We start by supporting restoration objectives that usually will also have a human health benefit in them. So you might want to look into not only contacting different conservation groups, but reaching out to senators and mayors and local health organizations, because not only do healthy waters mean healthy fish, healthy waters mean healthy people. And I'm sure in Florida you've seen with those harmful algal blooms, there's usually notices that go out, don't let your dog in the water, don't let your kids in the water, don't go swimming, because it's not just a matter of the water's dirty. Some of these harmful algal blooms are toxic and will create those, will be absorbed by the shellfish and create those kinds of really toxic things that can lead to just an upset stomach and some runs, to everything from cardiac arrest, amnesic shellfish poisoning, and it goes downhill really fast. So it's not just an environmental benefit, it is a human benefit to have these kinds of healthy ecosystems. And habitat restoration also combines with legal mandates for economic sensibility. And by that, I mean, if you have healthy waters, you're gonna have more people wanting to live there, you're gonna have an increase in the housing market, increase in tourism. It can get a little tricky because the intertidal zones are sometimes considered managed by towns, sometimes managed by states. It's very area specific who owns the bottom. So in some areas, the state might own the water, but the town owns the seabed. And because the oysters are on the bed but in the water, it creates a really fun political party to get those permitting requirements to get these kinds of projects up in the air. But if we can start pushing people to make these kinds of common sense decisions to help rehab these oyster reefs, there is a never-ending wonderfulness that will happen because of it. So, okay, so now I've talked about how can we do it, but like, has it worked? Am I just kind of talking out of my face hole? It has worked, and here is an oyster reef. I'm seeing Taylor just laugh at my hilarious puns because I'm the funniest person on the face of the planet. I am not. So there is a case study I'm going to talk about very briefly that was done in the Chesapeake, and this area they decided to make it no harvest. So not only do they have to consider, okay, so we're going to dump millions and millions and millions of shellfish into this area, but if it's still open to shellfishing, how do we keep them there? So if I go in and I dump 5 million oysters into the bay, and then Taylor comes in tomorrow with a rake and takes 500 of them for a clam bake she wants to have that night, well, now I'm 500 shellfish short. And if everyone keeps taking it, well, then I might as well have just taken my 5 million clams to a fish market and just sold them. So in this area, they decided to make it a no harvest. They were going to put them, leave them, nobody was allowed to touch them. So they looked at a combination of 94 different reefs that had been protected for a difference of 3 to 30 years. So these were 94 reefs within 11 different sanctuary sites around the Chesapeake Bay, and they were looking at density, biomass, and recruitment. And that just means how well were they spawning, what was the overall density of the population, and how densely were they packed. There were a lot of them that showed really great improvement. The longer protected areas showed the best, and the shorter ones were still showing great, but like not quite as well. And that's just because of the natural life cycle of an oyster. They demonstrated that after about 10 years of restoration, densities and recruitment not only met that level where they can now be ecologically successful, but they can also show fishery success. So by that, I mean, after 10 years of them kind of doing their own thing and being left alone, they've reached a critical mass point where they're now considered a stable system, and you don't have to worry about overfishing being as much of a problem. So in those ecosystems, you could then have some harm, and you won't have to worry about that dramatic decline that would happen again, like we saw in the 1880s and early 1900s. So overall for the Chesapeake Bay, it's looking pretty decent for the areas that are working well. They have a lot of different oyster management plans, whether it's to increase populations to self-sustaining levels so they won't have to continue to add more to those populations. People achieve sustainable fisheries, and not only just shellfish, but they're again recreational and commercial fisheries. They have seen reduce in the amount of harmful algae blooms and common diseases that are found in the water, and just increased hatchery and overall production. Depending on many different factors, salinity and ocean toxicity is also a
Is she frozen?
Yeah, still there, Rachel? Okay, I think she is frozen. We'll give her a second to load on back through. But if you do have any questions, throw those in the chat right now, because I think she only has 1 or 2 more slides left. And then she'll be able to answer questions. Yeah, there we go. Just lost her. There she is. Oop, you were unmuted, Rachel. I mean, you are muted, Rachel.
Hello, I'm so sorry.
That's fine. Did you want to try sharing for the last couple slides, or do you want to sum it up and go straight to questions?
I think I only have like 2 slides left, so let's attempt to finish it up. Give me 2
Perfect.
seconds. Okay, are we good? Okay. I think I was 1 slide back. Yeah. So it's just very quickly, the goal with oyster management and oyster conservation is just adaptive management that looks at different areas for different key factors and adjusts for those things. And then in conclusion, there's still a lot to be done. There's still a lot we can learn, but just ongoing checkups and ongoing adjustments are really the key. And that's it. That was it. So I will be happy to take questions now.
Yeah, if you could open the chat. Some people have been dropping them in there during the program. Otherwise, Sony, if you want to unmute yourself, you could go for it.
Can I tell my joke?
Absolutely.
Yes, please.
Okay, so what did the little shellfish say when he didn't share his toys?
What did he say?
Sorry, I'm a little shellfish. Get it? Because shellfish sounds like selfish.
I do.
Very
That was
nice.
fantastic. I absolutely love that one. I'm going to have
Put that one in your slide.
Yes. And I think I don't actually have access to the rest of the chat when it
Oh, no.
when I bumped out. I can't see the previous chats.
That's fine. I will read them off to you.
Sounds good.
We have, Keeper, I have a Brita filter pritcher. So is it dangerous to eat shellfish?
So it can be depending on where they're harvested from. So that's why it's also important when you go to your fisher's market, or if you're harvesting, always check the water quality. because there will be NOAA specifically and a bunch of other different local groups will put out water quality reports. So if you have an area that's experiencing a harmful algal bloom or the water quality has declined, they'll actually close some shellfish fisheries and say that it's not safe to harvest those. Usually in those areas, they won't make it to market. So if they have made it to market, it is safe to assume that they should be good, but it never hurts to ask where they're coming from to make sure that you can check for yourself if those waters are safe for you to be eating from. I think Sonia has a question too. She's raising her hand.
Also, can you guys move the Zoom meeting at 3 because my school is starting tomorrow and it ends at 2. So yeah.
Yeah, we did see a comment about that on Facebook. I brought it up to my supervisor and we were talking about it. So we have all of our August schedule already set in stone, I think, but we might be able to move September. We will definitely post about it and send out emails if and when that happens. But you're right, there are a lot of schools starting.
And also some people have a really dangerous allergy to shellfish and yeah.
They absolutely do. They absolutely do. And a lot of times those allergies are actually from the different things that the shellfish absorb. So it's not only...
I'm also really heavily allergic to nuts.
Oh yeah, no. I'm allergic to bread. So between the two of us, no peanut butter sandwiches for us.
No peanut butter sandwiches and no shellfish sandwiches. That doesn't even sound yummy.
No, it doesn't.
Here, wait, we have another question. Based on the population decline of shellfish, what can I do as a consumer?
As a consumer, I would recommend buying from small local fisheries if you can. Double checking to see where they're coming from. But also you can purchase your shellfish and look into different ways to help different organizations. I know with Chesapeake and I believe on Long Island and in New York City, there'll probably be something more local to Florida, I'm not sure, but they'll often have programs where you can go and raise your own oysters. You can help them raise them from spat-on shell to fully grown oysters. And then at the end of the season, in a year or two, you can keep a portion or a percentage of them, and then they will return the rest of the oysters to the bay. So those kinds of programs are really great to get involved in. They are 100% reliant on volunteers. I can definitely look into them and send Taylor a list of different places to call and to look into if that's something you guys are interested in.
Yeah, absolutely. Personal question, did they do that at SHRP? Did you get to take any of your shellfish home?
We did not start that program at SHRP. They did it for a little bit. I know Cornell Cooperative Extension in Suffolk County does it. They have a SPAC program where you can buy in and grow oysters out there. Some of it, even if you don't want to go out and get dirty, you can even just donate to them and then they'll take care of your bag. Nice. So if you want to donate and you don't want to get dirty, there are those options. If you're looking to get dirty and raise your own oysters, there are also those options as well.
We had someone ask, can you farm raise, aquaponic, aquaculture, raise shellfish and release them back into the ocean?
I'm sorry, I missed the beginning of that one.
Can you farm raise, aquaponics, aquaculture, any sort of at home raising them and then put them back in the ocean?
You absolutely can. I know in a lot of areas those restoration programs will grow and begin spawning them in the lab to create the highest success and survival rates for the small ones and then release those. I would hesitate to say grow them in your home, in your bathtub, and then release those, just because there are certain permitting requirements, and anytime you're releasing anything into the ocean, you have to be careful you're not adding an invasive species or anything along those lines. But we absolutely do rely very heavily on farm raised and aquaponics raised shellfish to get those numbers higher.
Yeah, an example of those invasive shellfish are definitely those zebra mussels everyone talks about that got released out into the areas that they shouldn't be in and then started clogging pipes and causing all these problems. And getting all into boats and mooring areas. So make sure that you're working with the proper organization with the proper permits. Are there any shellfish that are actually classified as threatened or endangered? Have there been significant policy reforms to protect against commercial fishing?
There haven't been any that have been listed as an endangered or threatened species that I believe, that I personally know of. I could be wrong. I think part of that is just because they're kind of everywhere. So while the populations have declined nearly 95% in some areas, they have the potential to come back rather quickly. So I think that's one of the reasons why they're not considered endangered or threatened in the same way that some marine mammals are listed. And the second, what was the second part of that question?
Have there been significant policy reforms to protect with like commercial fishing? Commercial fishing.
There have been, especially in those sanctuary and those restoration sites. So there have been policies put into place that will limit when you can fish, how much you can fish, when you can harvest, all of that kind of stuff. So it just depends on the area and what else is going on. And
then, do you think healthier shellfish populations would help prevent the annual red tides we get here in Florida?
Absolutely. If there weren't those, if there were more shellfish populations, all of that kind of stuff would be filtered out a lot easier. You wouldn't be able to eat those shellfish because they've now absorbed the red tide, but the red tide wouldn't be as much of a problem. And a lot of those things, especially in Florida, it's not just Florida, it's a matter of runoff coming from the north too. So in areas north of Florida where you see in like the Chesapeake Bay, if the Chesapeake Bay were to collect a lot of that stuff, it wouldn't flow south and south and south. And there's a lot of shellfish reefs before Florida that would stop a lot of that spread. Those harmful algal blooms like the red tide are also caused by things like fertilizer runoff and a lot of those excess nutrients. So shellfish in those barrier regions, especially in the marshlands, are key on preventing all of that toxicity from hitting your waterways and giving you those blooms you see every year.
Very cool. Matt wants to know, what is your least favorite shellfish? Counterpoint, do you have a favorite?
My least favorite shellfish. I think, least favorite shellfish. I think mussels, because they're so tiny. I feel like it's a lot of work for not a lot of gain. Favorite shellfish is anything my mom cooks because she is amazing and makes everything taste amazing 100% of the time. And once a year she'll do a big shellfish feast where we'll have clams and mussels and oysters and scallops, and it's just the best thing ever. It's the #1 recommended and requested dish when family from out of country comes in because it's just so yummy. It's so good.
Very nice. What temperature can oysters live at in the ocean? Is it a different temperature for like aquaculture, for lab grown?
They try to keep it about the same. So it usually around, once the water temperature hits like that 75-ish range, is when they're going to start waking up and do that broadcast spawning, which is why it's typically in those summer months. When it comes to those winter months, they just kind of go into just not really a hibernation, but like just a rather not kind of phase. But those kinds of specific temperatures, I do not know off the top of my head, but it's those like warmer summer months more than anything.
Which made me think of a question. I know that when they're doing aquaculture and like growing oysters and shellfish in a lab, lots of times they'll start off with just like the tiny ones and then grow them to adult size and set those guys free. Do you know if they either encourage or have accidentally had spawning events in a lab environment before?
I think accidental spawning is definitely a thing that could happen.
Yeah.
I think they try to maintain certain water temperatures to avoid those things. And usually what will happen is in a lab setting, they'll take 2 or 3 healthy adults and put them into like a small beaker and warm that individual beaker. And then like all of the spawned things are in the beaker. So it's a really concentrated batch of spawning. and then they'll release that into like a smaller tank to make sure it all mixes correctly. So it's a very small and condensed version of like large broadcast. But when it comes to those lab grown shellfish, they will typically wait until they're about the size of a quarter, if not a little bigger, before they release. Anything smaller than that is more likely to get eaten and stepped on and float away.
Very cool. Well, I don't see any other questions. We'll hang out for another minute, so if you have any, throw it in that chat. Otherwise, if you think of a question later, you can email it to MEEC, MEEC, @nova.edu. Oh, Sydney, what did you draw today? Oh, very cool.
Oh, that's so cool.
That's beautiful. Yeah, Sydney's our artist. She draws the topic of the day every time.
I love it. I also paint sometimes, Sydney.
You have some very nice drawings.
Yes.
If you
one thing I saw that was like a quarantine thing that people were doing, they were finding clam shells, and they were painting little like happy faces and like fun things in the shells, and then like leaving them in other people's yards.
Oh,
like
that'd
shells
be
of
cute.
Happiness. I thought that was super cute.
That is a very good
So
project.
if you find these shells, you can leave some at the MEEC for other people to find.
We would love to have some of those at the MEEC. We have our walls covered with donated pieces of art right now, and I'm sure that there would be a little space if you decide to donate any of your artwork. Yeah, if you want to send us pictures or if you want to send us questions, email us and I will definitely send them Rachel's way if we have any sort of problem, anything we can't answer. Ooh, thank you very much to the MEEC. Miss Silver was great. Yeah. In Canada, we paint rocks. Very nice. We do some rock painting here as well. Thank you for the super presentation. If you missed the beginning of this, it is recorded. It's going to go on our YouTube channel soon. Slowly but surely, we're editing and posting. And then this Thursday, we have Kelly Stewart coming in at 1 p.m. We are still talking about moving it to 3, Sony, so don't worry. But it will be all about leatherback sea turtle genetics. She tracks different families of leatherback sea turtles. So we will get to learn a little bit more about our turtley friends, but I'm very happy that we got to learn about shellfish today. So thank you so, so much, Rachel. Thank you. And everyone have an awesome time. Thanks from Montreal. Thanks. Bye, guys.